Welcome, greetings, and beautiful Sunday as we are going to start the conversion part 2. Already in the previous video, I have already done that decimal to binary conversion and how to get it back into the decimal format. Before even some hints about the decimal to octal and decimal to hexadecimal already have given, but still again I'll recall. It is good to recall because it helps you to retain the topic for the long time. Okay, so uh, just see here in which way we are going to do. All right. So the first thing is that decimal to octal, and I'm going to take example. My videos I won't make very fancy, a lot of animation and all, because I know students take a lot of time to join and they want to study, and already the burden of other subjects are also there. So without wasting the time, I'll come to the concept. So now here, for example, I'm going to take a number 973, which is in the decimal form. So student, again I will tell you, decimal means not the point value in computers. Okay, it is from 0 to 9 digits collection. Okay, so if I am going to take this number, okay, so let's see that how we have to write. We have to just do like this, 973, and keep dividing. Okay, so like 8 ones are 8. All right, so again here it is 1 and 7. All right, so what do you think? Okay, 8 twos are 16, it will go, and then finally 8 ones are 8, and then what remainder you are going to get? You are going to get the remainder 5. Okay, and keep doing rough calculation. If you want with a bigger number, don't take the risk. Okay, and if you think, you can do directly mentally. Here, what do you think? Okay, again 8 ones are 8, it will be, and all right, so 12 minus 8, you know very well how much it is. According to that, now it will be 8 5 7. All right, so what we will get? We will get the remainder 1, and then finally we have no chance at all. It is 1, and then after that we are going to get 7. Okay, because 15 minus 8 7. Now what happened here? We have got the answer. Okay, we have got the answer according to that 7. So I have told you bottom to top approach as usual. Fine. All right. And then two thing here, LSD and MSD means, L means the least significant digit. M is means maximum significant digit. It's very very important you to know. Okay, that these two things. Sometimes in exam they ask, they mention shortcut. Sometimes they mention uh, okay, the full form. So you have to just see that. Okay, so what happened, once you are dividing, okay, if you are just dividing the number, so very first remember, all right, just remember, for very first remainder becomes your least significant digit, and when the last remainder, it becomes the most significant digit. That is why bottom to top, it means what is the way that you have to note down. I have told you, we do not leave it. So 1, then 7, then again this 1, this 5, and finally our octal result is ready. So how you can say that we had 973, and then it was a decimal number, and then we got the answer. All right. Uh, Afterwards, do you recall? It means, are you feeling that what is happening? When we are taking the bigger number for the division, our steps are less now. All right. So, what idea you got? What is the key takeaway? That if when binary was sufficient, then why we are talking about the octal number or hexadecimal number? All right. It means maybe if I take 2 instead of 8. All right. So maybe 973 to divide, we must have taken complete one full page, and our division process would be quite long, right? So that is why new number patterns were also discovered. But apart from the two, why we cannot take 8 and 16? But again, you see that odd numbers were not taken. Okay, odd numbers were not taken, 2 and then directly 8, then just double of that, they have taken 16. Reason again I'm telling you, student, please remember that binary and only dividing and means only getting the data was not the main process. Actually the main problem comes storing of the data. Okay, storing of the data is that in the memory cell how each data is stored in the equal form, that is more concern thing about this. Okay, so how to make the data storage proper and calculative, even if sometime in this memory cell nothing is there. Okay, so what is done, that it is properly well calculated, and when extra space is there, of course that is called memory wastage also. All right, so what is that, then that extra memory which is not utilized at all, that is filled with the null value. Okay, because the concept says that it should be stored in this way, 8-bit only, 8-bit combination. All right, so here what we have seen now, how to make the process more faster. So what we have done, that we have taken 8, we have taken 16, and you can see how it can make the calculation quite fast. Okay, it can make the calculation very fast. And let's come to another number pattern. For example, I will take now hexadecimal. Before understanding hexadecimal, all right, I'll tell you why it is called hexa and decimal. Again you will get confused, why decimal over here. Okay, why decimal here. Okay, so you have to see that hexa means actually 6 and decimal means 6. So 10 plus 6, what is that, it is 16. All right, it is 16. All right, so that is why it is called hexadecimal, as it has no other meaning. Now, what are those 16 digits they are coming? Okay, what those 10 digits and plus 6 digits they are there. Okay, so 10, 0 to 9, of course, we will take, and then what is the rest thing? So, for the fair example, I would like to open the computer calculator. Actually, most of the time I present that computer calculator, I find that is quite, easy for me. So just give me 1 second. By the time you can keep revising, and if you are using the system, you can also open the calculator. Like I use this, you know, computer calculator. It is my best part, to understand and to show the real example. I do remember when I was a student, as a student, I even never know about this. Okay, I never know. And thank God, at least children today, they are learning the computer right from class 1 onwards. And they are, I think the generation is quite faster, but our people, yes, we have to, race with them. So I thank this generation, really, they are quite intelligent, brilliant. Okay, so let's come back to the topic. So here is the programmer, and if I go to the hex, okay, now what you see here automatically, what you see here, okay, this is a real calculator. Actually I'm showing the hexa calculator. So you can see here 0, 1, 2, 3, 4, 5. It is a normal thing. All right, till 9 here, and after that you will find out that A, B, C, D, E, F. So these 6 letters are there, you can see, and they are also in the capital letter. It means if something we present in the hexadecimal number system, so we will not present them. Okay, we will not present them in the small letter. Please avoid it. Okay, sometimes you say, what is the difference? No, in computer it matters a lot. I'm telling you, if you write capital A and if you write small a, computer treat both of them in a very different manner. Okay, so make sure that do not treat, okay, that capital A and small a is quite similar. For computer it's not. So let's come back to the calculator again. So here you can see that A to F they have given here, and then 0 to 9 digit there. It means this is the combination actually of the hexadecimal. Okay, this is the best way to understand. All right, so let's come back conversion. All right, so it means whenever if 0 to 9, if any remainder is coming, it's okay. But if the remainder comes 10, 11, 12, 13, 14, 15, you are going to represent them with the help of the letter A. Means again I'm telling you, if the remainder comes 10, so you will calculation time it's okay, but the final time means the way you are going to represent the answer. 10 you will write down as A, okay. 11 you will write down as B, 12 you will write down as C, and so on, means till 15. Till 15 it will go like this, okay. So 10, 11, 12, 13, 14, 15. So which alphabet will follow? Will follow like A, B, C, D, E, and F. Okay, I hope this much it's clear. Okay, so let's see further. All right, so quickly can we take one example and can we start? All right, good. So I'm going to take a number and I will take quite big number. Why to waste the time in the smaller number? Okay, yes, if we have a bigger number means it is easy to take more bigger number to divide and convert. Okay, why? If we have more facility, why to waste the memory as well as the time? So here I will take 16. Now you can see what you can say. Okay, 199. So it's easy. Okay, so 16 ones are 16. Okay, after that, yes, just do the mental calculation, then 2, and then finally it is 3, and I'm getting the remainder 5. All right, and after this, next is directly I will take 16 sevens will be okay. Okay, yes, and then finally we are going to get 11. Now you see what is that, and it is your first remainder, so you can say it is LSD, least significant digit, and 11 it is the final and the last one, so we can say that it is sorry, this one 7 also, how come we can forget the 7? Okay, so 7 is your MSD, and you can keep writing once you keep solving. All right, so here again bottom to top approach. All right, so what was that? 1973, it was your uh, decimal number, and its answer what we have got? We have got 7, we have got, and then I will write separately. Okay, and 7 and then 11 and then 5, but actual we will write down 7, it's okay. 11 we cannot write in that way, so I will convert into the P. Okay, because 11 stands for P, and then 5 we can note down as it is. So final representation is this, means this one. Okay, I will not take this. All right, so just remember that how to get these and yes, if you take 16 you will not get remainder more than 15. It's automatically the calculation is well prepared in this manner. All right, so this was the conversion. Okay, this was the conversion decimal to a binary and octal and then hexa. All right, so I think this is very clear. If you want some question, you frame yourself. You know why? And today's generation, we say that frame your question yourself. Reason is that you will also come to know that how to you know frame good question. Reason is that in exam time when question comes, then it is a difficult thing, because we do not know what is the pros and cons of the question framing. Sometimes the question is too difficult, sometimes the question is less difficult. So what do you think that in which way we can do it? Okay, so you should learn that how you can frame your own question. Okay, so I hope you have understood very well. Okay, now binary to decimal conversion, I'll come to now opposite. Can we go to opposite? Means now I will go binary to decimal. Means if the number is binary, then what we should do? If the number is octal, then what we should do? And if the number is hex, what we can do? Means every conversion binary is given, so how to convert them back. And sometime in exam I have noticed that it comes for the verification. How? Remember in your small classes it was always given that verify your division. How to verify that your answer is correct? So what you do? You multiply the division divisor, and then finally you add the remainder, and then you verify. So here also sometime it is again asked for the verification, that you do it, convert back, and then are you going to get the same answer, yes or no? All right, so this In previous video, first of all, already I have shown, already I have shown how to convert it. Okay, this conversion already